this is the 2022 deferred exam. Okay. And it is the interpenetration or intersection of solids topic, question B1. And so we're going to start this question is with the plan view of the cuboid, or cube, sorry. Yes? You? I think you know the answer. So the inclination of this triangular prism is 15 degrees. Sorry, 20 degrees. So from the horizontal line, the XY line, I'm going to measure up 20 degrees. Put my little mark. And then draw my inclination. Gosh. I'll have to be rubbing that button out. So then for the triangle, I'm going to take this point as my bottom point, okay, and I'm going to rotate them by 15 degrees, which is to there. Okay, so this prism is angled at 20 degrees, then you have your 15 degrees added to that, and it is a full measurement of 60 millimeters each side. So once I have that measured, I'll take my compass, I'll set it to 60, draw an arc from one side of it and draw an arc from the other side of it to get the third point. So this can be point 1, 2 and 3. We join them together and that will give me my equilateral triangle. Now the next thing I also have to do is I have to bring these lines down to take my measurement so that I can draw my plan view. So I'm going to take point 2 and bring it down, point 3 and bring it down. And I'm going to take my measurement from the front to the back from here. So these measurements of 1, 2 and 3 from front, this is the back to front. I'm going to take with my compass and apply them then down to my plan. But before I do that, I'm going to generate them into my front elevation view using sliding set squares. So I'll take my 20 degree inclination. I'll slide it up to point number 3 and I'll continue it down. Slide it up to point number 2, continue it down. Okay, and then I'll take with my compass, I'll take those distances of 1 to 2, 1 to 3. So there's a distance with my compass of 1 to 2, and I'll apply it to the distance of this line here. So that's where line 2 is going to be located, and then I apply the distance from 1 to 3. And that's where 3 is located. And so I'll draw these in then. The rule of thumb here for this then is So I'll go around and I'll label it now. This is line 3, so this here is line 3 and line 3. Again, this is at a 20-degree angle incline, and this then is at 90 degrees to that. Therefore that looks like that. This is line 2 and this is line 1. This is line 1. That's line 2, line 3 and line 2. So three goes to 2, 2 goes to 1. One goes to 3, 3 goes to 2. Okay, so we have what's provided to us, given so far, and now what we need to do is we need to draw our second auxiliary view, looking down here at 20 degrees. So I'll create my x2, y2. Create an ML, which is a measuring line. And I'll bring all these points down at 15 degrees. Help me with drawing the auxiliary view. So what I'm going to do now is going to label my cube. So this will be corner A, corner B, corner C and corner D. So this will be B, B, A and A, D and D, C and C. And then I'll just transfer those measurements over to here. So I will take the measurements from the measuring line, which is corner B here. Okay, so corner B is bang on the measuring line, which means that this is going to be B, and that's B there. And then we'll measure to the next nearest point, which is to C and also to 1. So I'll take the height of C here, take that measurement, mark it in. Take the measurement of the bottom of C. So from the measuring line to C, measuring line to C, transfer those labels, and then I will go to the next line, which is going to be from the measuring line to 2. Oh, forgot to do point 1 as well. So line 1 comes along that way and goes there. Then we take the measurement of point 2. Line 2 goes here. And the next measurement then is to point A. So we take that measurement for the bottom of A and for the top of A. Label them. And then take the measurement for 3 is the next one. And then the last measurement is from the measuring line down to T. So remember the rule, back 2 views gets you the measurements. So there's my measurement from there to D. You can just about see that. Bring that down there. Okay, and I'm just going to join them up now. So A goes to B, B goes to C. A to B is at the back, so it's not going to be visible. So it's going to be a dashed line. B goes to C, which is visible. No, it's not visible either. Sorry, it is visible from there. C to D is visible. And A to D from the side view is not visible either. C to C is visible, goes through point 1. B to B is visible, D to D is visible, and A is hidden. Okay, so this is our view down here, and if you wanted to just make things a little bit easier for yourself, you could colour the surfaces of entry and exit of the triangular prism into the cube in different colours for entry and exits. For the sake of a couple of seconds, it definitely will help with visualization and solving. I would highly recommend it. We're just trying to get the point across here off. So this red surface that I'm colouring in at the minute, there's no entry or exit on it. Okay. And that would be CB, which is this line here. This surface is red. This surface here, B or CD, is green. You can colour this a different surface or different colour if you wish. So we could go orange. And we can go light colour blue for this one back here. So AB is a blue surface. Okay, so talking about now getting our lines of intersection, our points of intersection, we're looking at edge 1 will come down and enter and penetrate at point C. So it stops at point C, and that's where it penetrates the object. So therefore 1 will come along and penetrate at C. It goes all the way through the object, then through the middle, and exits on the surface AB, which is on this surface here. It exits on that surface, so therefore it comes out there. So that is our exit point, and that is our entry point. So therefore with line 1 down here, we can transfer one to the other and get that line or that point of intersection. So that's my starting point, and what I want to do then is create a loop around. So I'm going to go from 1 to 3. Why can I go directly from 1 to 3? Because both enter and penetrate the green surface with no turning points. So my entry kind of loop is as follows. It's 1 to 3 to turning point T. Okay, to 2, okay, to OR, and then to 1 again. So that's my entry, so I'm going to find those points now. So I can go directly from 1 to 3. 3 enters on the green surface CD, so that means that it stops there, or sorry, enters there. So I can bring that up as far as line 3, which will be here. So therefore line 3 is going to enter and stop at that point. So 1 will go directly to 3, and I was going in a clockwise motion for that loop. And so 1 stops there and goes directly to 3. Okay, and then we're going to go to turning point T. T is on the line DC. We can just bring that up at the same angle of 15 degrees until it hits the line DC.
Thanks, sir.
No problem. There's line T, so that's up to hit turning point T. Bring turning point T down here to the line DC. and there's turning point T. Then it goes to 2, and 2 enters the pink surface, which is ABCD, which is this top surface here, and so therefore we're going to need an element. So I create a green line here going from A through line 2 or point 2 until it hits the CB surface. I'll bring that green line or green point up until the CB surface. There. So across here it's just going to be a horizontal line, but in my plan view it will give me some information. So there we are there. And in my plan view I can bring that down here to my DC, or sorry, CB, and this is on the CB line here, just there, which means if I draw this green line on the top surface to there, wherever line 2 meets it is its stopping point. So line 2 will come along, meet that, and that's the stopping point for 2. Sorry, again. 2, so I can bring that point up, and I can find point 2 up here, which, as you can see, match perfectly. So I suppose in essence I didn't have to do the element line because I should have just known that that was coming down and hitting that. That was an edge view of that surface. I didn't actually have to do that element, but doing the element just proves that the technique works, and I found the exact same information using both. So it's going to go from T to 2, which is across the top surface, so it'll go from T to 2 here. And then it's going to go to or is a turning point on surface DC. Maybe if I do subliminal messaging into the camera, I might get second paid. Anyway, so what I'm trying to do here is I'm trying to take this this triangular prism and enter into the object, into the cube, and so my path of that entry is 1 to 3 to T to 2 to or back to 1 again. So we're starting at 1 here on this point, entering, then going to 3. That's a straight line because it's entering on the same surface, which is the green surface. Then we want to go to 2, but we can't because 2 is on a different surface, so we have to go to the turning point T first, then go to 2, then go to or, and then or and 1 are on the same surface, so we can join them together. So I have so far on this, I have 1, I found 3, I found T, I found 2, and I found or, if I'm not mistaken. No, I haven't found or yet, so I have to find or. So or is here, it's on the line DC at the top. So if I take my 20-degree line and I bring that or point up to the line DC, it hits here. So therefore, if I bring that back down to my plan view on the same line, we'll be finding and discovering where or is. So or then is on the line DC. Or is on the line DC here, so it goes from 2 to DC, which is here. And so therefore it goes back to that location there. And then it will go from or back to 1 again, which is back here. So if I was to color this blue object, the blue prism entering the cuboid, or cube, sorry, we're talking about it entering in that vein there. Does that make sense? And again, up here at the top, or is there. What is visual or visible from one part to the other is the following. Okay, So then we're going to work on our exit point, and the same strategy applies. So we're going to go from one and loop round in the triangle, but we have to consider the exits on this side over here. So we're kind of engaging different surfaces. So we're engaging the blue surface AB and the orange surface AD, which aren't exactly drawn there, but you could go over them and colour them in if you wanted to for this section. So one exits on surface AABB. So let's find that over here. So AABB is an edge view in this view, so therefore it hits it perfectly up there. You can label that as where one exits. Then it's going to go straight to tree, and tree will exit on surface DA. Again, DA is sorry, the exit, there's a turning point on the exit then, because the exit on different surfaces. So this is point Q, we call it. So the turning point 1 to Q to R, so exit. The exit loop goes from 1 to Q to tree to we'll say V to 2 to 1 again. Okay, so that's our exit loop. So we just have to find those points again on this surface. So we find Q. So we're looking for Q. Q is on the line AA. So if I can bring that up at the exact same angle, which is 20 degrees, bring Q up until it hits the line AA, and that gives us its location of Q. The line will go from 1 to Q. Now, will I see that visible line? I will, because I can see the underside of it. Tree stops here. So it'll go from 1 to Q to tree. That actually should be a dashed line now that I think about it and look at it. Okay, so it's a dashed line. So it goes from 1 to Q to tree. Then we're going to go to V, and V is on again the line AA. So let's try and find that at the 20-degree angle. Trying not to get tip X everywhere. It goes from tree to V. And then from V to 2, and again 2 exits on a vertical surface, so we can bring that just up to 2. Okay, 2 over here. V will go to 2. It's on the back side, so we won't see it, so it'll be hidden detail. And then 2 will go straight to 1 because it's on the same surface or sharing the same surface, and again that's going to be hidden detail because it's on a surface behind the object where we can't see. So again, if I was to colour in this object, this is the way it goes. In the middle of that question there, or for this point 2, I did use an elements method. I actually didn't need to use it in the end, but I suppose it's good to know that if you needed to use that technique, it's available to you. It has benefits in some questions, but I didn't need it in this question because I had the edge view of a surface. So therefore I didn't need it. Okay. And just for this, we'll do the cube in brown. Actually, that's supposed to be an orange surface. No, AD, doesn't matter. Brown, orange, same thing. Then the surface is green. And if I just go around with solid pen, then we have the solution done. Okay, so that's that question done, solved, and if there's any questions on that, sure, just let me know.